This video is only for quick revision with no extra discussion. In part 4, we will solve the in-text and exercise questions from the chapter Matter in Our Surroundings. I will read the question and answer, and we will focus only on the main idea. You don't need to remember long explanation, just important word. Remember one simple rule: matter has mass and occupies space. Now let us start with in-text question number 1. Which of the following are matter? Chair, air, love, smell, hate, element, thought, cold, lemon water, smell of perfume. Chair, air, element, lemon water and smell of perfume are matter because they occupy space and have mass. Love, hate, thought and cold are not matter as they are emotions or sensations and do not occupy space or have mass. Next. Give reason for following observation. The smell of hot sizzling food reaches you several meters away, but to get the smell from the cold food, you have to go too close. The smell of hot sizzling food reaches us from a distance because at higher temperature, the particles of aroma gain more kinetic energy and diffuse faster in air. In cold food, the particles have less kinetic energy, so diffusion is slower and we need to go closer to smell it. The key word is diffusion. Next. A diver is able to cut through water in swimming pool. Which property of matter does this observation show? This observation shows that the particles of matter have space between them and attract each other with a moderate force, allowing a diver to move through water. Remember, water particles attract each other but not strongly enough to stop the movement. Next. What are the characteristics of particles of matter? The characteristics of particle of matter are: particles of matter have space between them, particles of matter are continuously moving, that is, they possess kinetic energy, particles of matter attract each other. This is very important and direct question. Now we move ahead. The mass per unit volume of a substance is called density. Arrange the following in order of increasing density: air, exhaust from chimney, honey, water, chalk, cotton and iron. The order of increasing density is exhaust from chimney, air, cotton, water, honey, chalk and iron. Exhaust from chimney is considered less dense than air because it is hot and rises. Remember, always arrange from least to highest carefully. Next slide. Tabulate the differences in characteristics of state of matter. Solid have definite shape, liquid and gases have no fixed shape. Solid and liquid have fixed volume, gases have no fixed volume. Compressibility is negligible in solid, very low in liquid, and highly compressible are gases. Diffusion is very slow in solid state, faster than solid in liquid state, and very fast in gaseous state. Solids are rigid, liquid and gases are fluid. Kinetic energy is least in solid, higher than solid in liquids, maximum in gaseous state. This table comprises solid, liquid and gas. Understand the pattern and then learn this table. Next. Comment upon following: rigidity, compressibility, fluidity, filling a gas container, shape, kinetic energy and density. Rigidity. Rigidity is a property of matter by which it resists change in its shape. Example, a wooden table is rigid because its shape does not change easily. Compressibility. Compressibility is a property of matter by which its volume decreases on applying pressure. Example, gases are highly compressible, so LPG and CNG are stored in cylinders. Fluidity. Fluidity is ability of substance to flow. Example, liquid like water and gases like air can flow, so they show fluidity. Filling gas container. Gases can completely fill the container in which they are kept because the gas particles have large space between them and move freely in all directions. Example, air fills a balloon completely when it's blown. Shape. Shape refers to the definite boundary of a substance. Example, a book has fixed shape, water takes the shape of container and air has no fixed shape. Kinetic energy. Kinetic energy is the energy possessed by the particles due to their motion. Example, gas particles have maximum kinetic energy, so they move very fast. Density. Density is defined as mass per unit volume of substance. Example, solids are generally higher density than liquid and gases. For example, iron is denser than water. Next. Gas fills completely the vessel in which it is kept. A gas fills vessels completely because its particles move randomly at very high speed and have large space between them, allowing them to spread in all directions and occupy the entire container. Keyword is random motion. Next slide. A gas exerts pressure on the walls of container. A gas exerts pressure on the walls of container because its particles move randomly at high speed and continuously collide with the walls of container. These collisions exert force per unit area on the wall, which is called pressure. Next. A wooden table should be called a solid. A wooden table is called a solid because it has definite shape, fixed volume, and rigid due to the strong force of attraction between its particles. Next. We can easily move our hand in air but not through wood. We can easily move our hand in air because air particles have large space between them and very weak force of attraction. In wood, particles are closely packed with the strong force of attraction, so it is difficult to move our hand through it. Next. Liquid generally have lower density than solid. Why does ice float on water? Ice float on water because the density of ice is less than the density of water. When water freezes to form ice, its particles arrange themselves in open structure, increasing the volume and decreasing the density. Next. Convert the following temperatures from Kelvin to Celsius. We will use the formula degree Celsius is equal to Kelvin minus 273. Part A, 300 Kelvin. Degree Celsius is equal to 300 minus 273 is equal to 27 degrees Celsius. Part B, 573 Kelvin. Degree Celsius is equal to 573 minus 273 is equal to 300 degrees Celsius. Next. Physical state of water at 250 degrees Celsius and 100 degrees Celsius. As 250 degree is much higher than the boiling point of water, so water exists in gaseous state. At 100 degrees Celsius, water is at its boiling point, so both liquid water and water vapor are present. Next. Why does temperature remain constant during change of state? During change of state, the heat supplied is used as latent heat to overcome the force of attraction between particles, not to increase the temperature. Here the keyword is latent heat. Next. Suggest a method to liquefy atmospheric gases. Atmospheric gases can be liquefied by increasing pressure and lowering temperature. Next. Why does a desert cooler cool better on hot dry day? On hot dry day, the rate of evaporation is high due to high temperature and low humidity. Evaporation causes cooling, so the desert cooler cools better. Next. Why does acetone or perfume feel cold on the skin? Acetone or perfume evaporates quickly. During evaporation, it absorbs heat from the skin, causing the cooling effect. Next. Why can we sip tea faster from a saucer? Tea is spread over a large surface area in saucer, which increases the rate of evaporation and causes faster cooling. Hence, we can sip it faster. Next. What clothes should we wear in summer? We should wear cotton clothes in summer because they absorb sweat and allows easy evaporation, which cools the body. Next. How can Celsius temperature be converted into Kelvin? By adding 273 to the Celsius temperature. Next. Convert 293 Kelvin to degree Celsius. We will use the formula degree Celsius is equal to Kelvin minus 273. 293 minus 273 is equal to 20 degrees Celsius. Again the temperature conversion. Next. Convert 470 Kelvin to degree Celsius. We will use the formula degree Celsius is equal to Kelvin minus 273, that is 470 minus 273 is equal to 197 degrees Celsius. Next. Convert 25 degrees Celsius to Kelvin. Kelvin is equal to degree Celsius plus 273. So the answer will be 298 Kelvin. Next. Convert 373 degree Celsius to Kelvin. Kelvin is equal to degree Celsius plus 273. 373 plus 273 is equal to 646 Kelvin. Why do naphthalene ball disappear? Naphthalene ball disappear due to sublimation, in which the solid naphthalene directly changes into vapor without changing into the liquid state. Next. Give reasons for the following observation. We can get the smell of perfume sitting several meters away. Perfume is a volatile and evaporates easily. Its vapor diffuses rapidly into air due to high speed and large space between gas particles, allowing the smell to spread several meters away. Next, arrange the water, sugar and oxygen in increasing order of force of attraction. The order will be oxygen, water and sugar. Force of attraction is minimum in gas, more in liquid and maximum in solid. Next. What is the state of water at 25 degrees Celsius? At 25 degree, the temperature is above the melting point and below the boiling point of water. Therefore, the water exists in the liquid state. Next. What is the state of water at 0 degrees Celsius? It will be solid and liquid. 0 degree is the melting point of ice. At this temperature, ice starts melting into water. So both solid and liquid states can exist together. Next. What is the state of water at 100 degrees Celsius? Liquid and gas. 100 degrees Celsius is a boiling point of water. At this temperature, water starts changing into steams. So both liquid and gaseous states can exist together. Next. Why is water liquid at room temperature? Water is a liquid at room temperature because it has fixed volume but no fixed shape and it can flow. At room temperature, the intermolecular force attraction in water is strong enough to keep particles close together but not strong enough to fix them in position. So water shows fluidity. Why is iron almirah a solid? An iron almirah is a solid because it has fixed shape and it's rigid. The particles in the solid have very strong intermolecular force of attraction and are closely packed so they cannot move freely. Next. Why is ice at 273 Kelvin more effective in cooling than water at same temperature? Ice at 273 Kelvin is more effective in cooling because of its latent heat of fusion. Ice absorbs latent heat of fusion from surrounding to change into water without a rise in temperature, thus producing a greater cooling effect. Next. What causes more severe burn, boiling water or steam? Steam causes more severe burn than boiling water. Steam contains latent heat of vaporization. When steam comes in contact with skin, it condenses into water and releases its latent heat, causing more severe burn. Now we will see the last question from the chapter. Name A, B, C, D, E and F in the following diagram showing the change in its state. In this diagram, we can see the three states of matter, solid, liquid and gas, and the processes by which one state change into another. A. Melting solid into liquid. D. Freezing or solidification, liquid into solid. B. Vaporization or evaporation, liquid into gas. C. Condensation, gas into liquid. E. Sublimation, solid into gas directly. F. Deposition, gas into solid. Thus, A, B, C, D, E and F shows different processes involved in change of state of matter. This chapter has been covered in 4 well-structured parts. The first 3 parts include all possible questions from every line of the chapter's text, ensuring nothing is left out. Part 4 covers all-in-one text and exercise questions. All questions are presented in ready-to-write, exam-oriented question and answer format. No extra discussion, helping you to revise chapter quickly and effectively. By watching these videos, you can use your free time wisely and achieve a complete revision of chapter in one place. Thanks for watching. If you found this helpful, please like, subscribe and share with your friends so you don't miss out such a complete chapter-wise revisions.